Pre-Calculus, Chapter 4, Lesson 5, and we're going to look at three functions in this video and their graphs. And we should be able to do this fairly quickly because these three functions are the reciprocal of three functions that we've already looked at. We looked at the sine, so we'll look at the cosecant. We've looked at the cosine, so we'll look at the secant. And we've looked at the tangent, so we'll look at the cotangent. And we're going to start with the cotangent. The tangent, you remember, of an angle, or the tangent function, I don't know why I wrote that all the way out, but I just felt like it, you remember is the value of the sine over the cosine. And because the cosine was in the denominator, wherever the cosine function was 0, we had an asymptote at that point in the tangent function. Well, the cotangent is the reciprocal of the tangent, so we're going to have not sine over cosine, but we're going to have the cosine over sine. So now the sine is in the denominator. So just like we had asymptotes where this cosine was 0, we're going to have asymptotes with the cotangent where the sine value is 0. So if we have the sine function here, we have a 0 here on the y-axis, and then we have a 0 here, and we are going to put one on the other side here. And again, you can see that these go on in both directions everywhere that the sine value has a 0. So you remember that once we have the period, we divide this into 4 equal sections. So we divide this in half, and then we divide those halves in half, and then we have these points. Now, the cotangent is the reciprocal, which means these values are going to be flipped. So rather than going the pattern -1, 0, 1, we're going to go 1, 0, -1. So the cotangent is the kind of flipped version of the tangent. So at the first 45-degree angle, we're at a +1. At the next 45, we're at 0. And at the next 45, we're at -1. And so the cotangent looks exactly like almost a reflection of the tangent function. So then we would divide those, and again, this is going to repeat. So we have 1, 0, and -1. And then this would just repeat. So our cotangent function, again, looks very much like the tangent, and which it kind of makes sense because it is a reciprocal. So it would look something like this. So we have zeros at the places where the sine is 0, or we have asymptotes, excuse me, where we have the sine value is 0, rather than the cosine because of the reciprocal function. All right. So that's the cotangent functions. And then, like always, all the reflections and everything still apply, and the period of the cotangent matches the period of the tangent. They both have a period of pi. So while we have the sine function here, why don't we go ahead and take a look at its reciprocal, the cosecant. So the cosecant is the reciprocal of the sine, meaning it's 1 over the sine. Now again, because the sine value is in the denominator, wherever the value of the sine function is 0, its reciprocal, the cosecant, is going to have an asymptote. So that's why I left these asymptotes here, because this is where the sine value is 0. Now, because it's reciprocal, let's take a look at what happens to the function. If you think about the reciprocal, as you get bigger and bigger numbers, if you took the reciprocal, what would that mean? Well, the denominator would be getting bigger and bigger, so the actual value of the function would be getting smaller and smaller. So as the sine value is increasing, its reciprocal, the cosine, is going to be decreasing. So it's going to be coming down. Now it's going to reach a value of 1 right here. Then as the sine value begins to drop, the numerator, the denominator, begins to get smaller, then the value is going to get bigger, and so the cosecant looks like this. And then on the negative side, it's still going down. It's getting smaller from the negative value, so this is still getting bigger. As it reaches here, as this starts to get bigger, the cosecant then begins to get smaller. So it looks like this. And then you have this repeating pattern as going each direction. So the asymptotes are the asymptote. If it's negative, it's getting negative. And again, as it's getting bigger, the cosecant is getting smaller, and as it's getting smaller, it's getting bigger, etc., etc. There's another asymptote right here. Okay, so the cosecant function looks like this. Now, let's take a look at the secant function, which is the reciprocal of the cosine function. So here I have the cosine function, and again, if we think about the reciprocal, we have the cosine of theta. The secant function is the reciprocal, which would be 1 over the cosine. So wherever the cosine is 0, we're going to have asymptotes. So I have my asymptotes here from when we were doing the tangent function. And again, just like the sine function, as these cosine values get bigger, the secant function would be getting smaller, and as it gets smaller, the secant values get bigger. Now again, this is centered around the origin, where you remember this one is not. So again, it's simply a shift of pi over 2 units to the left, because that's what the shift is. So it makes sense that the secant and cosecant functions look very similar to each other, because one is related to the sine and one's related to cosine, and those are related to each other as well. So you have these functions that look like this. Okay, so those are pretty easy, I think, if we just know that they're reciprocals, and as denominators are 0, we have asymptotes, and then as one is increasing, the other one's decreasing, and vice versa. So those are the 6 trigonometric functions. Those are what they look like. You should be able to graph those. Again, all the horizontal shifts, stretches, period, all that stuff that's affected by the b values, etc., are all exactly the same for the reciprocal functions as they are for their original or their base functions. I don't know what we would call them, but the reciprocal functions of each other. So the period of the cosine and sine is 2 pi. The periods of the reciprocals, however, is pi, because we have these asymptotes, because the zeros occur at every pi units. Okay, so we'll take a look at one more thing in this chapter and this lesson, and then we'll wrap this up.